So we looked at three examples where we were given either coordinate points or a mapping diagram. None of those three wound up being one-to-one functions. So we do want to take a look at an example of something that is a one-to-one function, and also wouldn't it be great if we didn't have to look at individual coordinate points? That would be swell. Well, we have a test that can help us out when we have things that are graphed, when we're looking at a picture instead of just a bunch of points, which is why we spend so much time graphing in previous units. Graphs really are helpful. So we have a vertical line test. Note the difference between these two. Horizontal is a line that goes this way. Vertical is a line that goes up and down. So we have a vertical line test that tells us whether something is a function. That's a test that we used back in first semester. If I just throw in a random slide here really quick, the vertical line test, let's say I had a function that looks like this. It's a parabola. The vertical line test was just drawing a bunch of vertical lines. If any one of those lines touched more than one point, it was not a function. So this passes the vertical line test. It is a function. If I were to kick that parabola over on its side, though, it's possible to find a vertical line that touches more than one point. So that's a semester one topic. We haven't played with it in a while, but the vertical line test allows you to see if a relation is a function. The horizontal line test, now we're using horizontal lines and tons of green highlighter, can be used to determine whether an inverse is a function. So keep in mind, that's what we were just doing with coordinate points. Now we can really quickly do it with a graph. So both the relation and its inverse need to be functions in order to have that one-to-one relationship. So if we take a look at 4 is just a plain old line here. Let's make the vertical lines blue. We'll do the horizontal in green. So if we take a look, we'll start first with the vertical line test, the old one. No matter how many vertical lines I draw, each one is only going to touch this relation in one spot. So this is a function. And if I start looking at horizontal lines, likewise, no matter how many horizontal lines I draw, they are also only going to touch that line in one place. So the inverse is a function too. Let's compare that to number 5 over here on the right. Once again, no matter how many vertical lines I draw, they are only going to touch that graph in one place. So my original is a function. Let's try something fun. Copy. Paste. Ooh, that was exciting. Unfortunately, when I draw a horizontal line, it touches in 3 points. And I could draw other horizontal lines as well, but you only need one of them to fail that horizontal line test. So my inverse is not a function. So using our new vocabulary, we can say that this first example here is one-to-one. Well, here we go. Our first example is one-to-one because both the function and its inverse are functions. So unlike the examples we looked at previously, both of these guys are functions. Unfortunately, in our new one, this is kind of like the very first coordinate pair example we looked at, where the original relation is a function, but the inverse isn't. This is what that looks like in graphing form. So this one is not one-to-one. So at this point, we've seen a couple of graphs, we've seen a mapping diagram, we've played around with coordinates. Go ahead and try the first couple practice problems on the attached worksheet. They're very much like this. We're either drawing horizontal lines or switching X's and Y's. Not too intense just yet. In the second section, we're going to look at how to actually find an inverse once you know that an inverse does exist. So stay tuned for that. Definitely try those practice problems before moving on.